Year 6. I hope you're well and have had a good day today so far. In our maths today, our recap session, we're going to look back to the algebra assessment we recently did. Now, as you know, guys, me and my computer and I are having a few battles. So what I'm going to try and do is, as we go through the questions, I'm going to demonstrate how I do them using the computer. If it goes a bit strange, I apologize. To be successful in today's session, then, we're going to understand the key elements of algebra. We're going to understand the approaches which could have helped you solve some questions. We're going to solve questions linked to those key concepts, and we're going to think about those. So the basics then. We've got the ideas of expressions and some other terminology. So expressions then, substitution and formula. And hopefully we're going to revisit quickly what they mean before we then carry on. But expressions would be ways of showing something that's happening, basically. So the expression which causes the given output. So if you see that the blue circle has 3 yellow triangles added to, so it's plus 3. So the expression will be a plus 3. Now, if we have the green square, if we added 3 to that, it would be b plus 3. Okay, so the expression there is what's happening to the original letter to then become the new output. Okay, so expressions. Then we've got substitution. Substitution is when we change something. Okay, so we change a value. So here we've got idea that we've got to substitute the expression for a beginning value. So if we've got 2b plus 2a, I'm in the way of the values, aren't I there, guys? Sorry. But if a equals 5, so a is 5, and b is 3.5, well, a plus a, that's 2a, would be 10. B plus B, so double 3.5 will be 7. Then we've got 10 plus 7, so 17. For Sam, we've got 2b, so that's 3.5 plus 3.5, so 7. And then we're adding 3.5 plus 3.5 to 5. Okay, so we're multiplying, aren't we? So it's 7 multiplied by 5, and therefore it's 35. It's 35. Sorry, I said that incorrectly, didn't I, guys? But there we're substituting the values for the expression that we've got. And finally, we've got formulae. And here, this is the way that we represent things as calculations. Okay, here we can see that rather than having numbers, we sometimes just have the letters to demonstrate what we're showing. So here, the perimeter of somewhere is 2a. So the formula is that the perimeter is 2a plus 2b equals b. Okay. So here we've got, okay, so this is the expression, a plus 3. This is the substitution where we're changing the values of the letters for the numbers. And the formula, finally, is the idea, final representation of a calculation. Okay, so which one's correct here? So we've got calculation, expression, and formula. The first one is the one with the equal sign, which is the idea of the formula where we don't have any numbers at that point. The second one is an expression because we don't have it equating to anything, equaling something. And the final one is the calculation where we solve a problem and we get an equals a value, which is means something to us at this point. So we can see the 10. Not to worry too much about these because I think it's how you use them that's key rather than the specific terminology. So this is the assessment you did. And I was really impressed by how well you did it. And people such as Chloe, and I think AXA, and I'm trying to remember Fatima, but quite a few of you, with question 2, if you didn't have a printer, I know it's frustrating, but what you did was you solved it anyway. And you laid it out really professionally and really maturely. So thank you for that. We'll go for each question. That's the way I thought we'd do it. And I'm going to try now using my dodgy old tech to bring up the skills. Okay, so this is the function machine here. Okay, so we can see that the input has 5 added to it, and then we complete it. So when the input is 7, the output. So if I've got 7 here, so sometimes what actually helps is to write it on the page. I've got 7, and I'm sorry the handwriting isn't very precise there, Karen. I know it upsets you when my handwriting's dodgy. And I'm adding 5 to 7, then I know that the output is going to be 12. Okay. Now, when the input is something, the output is 7. Well, here I've got 7. And before I had 7, I plussed 5. I added 5 to my original value, which was here. Now, what would I plus 5 to make an output that would be 7? Well, I know 7 goes with 5 to make 2, as in that 7 subtract 5 makes 2, because I'm going the inverse route because I've going the opposite way. Rather than adding, if I'm going this way, I'm going to subtract, and therefore I end up with 2. Okay. Let's see if we'll go forward now. This is the bit where Mr. Spring's tech doesn't work very well. That's it. There we go. Lovely job. Okay, and this was the second question. So here you had a star, which was worth 6, a smiley face, which is worth 8, because a smiley face is always very, very valuable. Okay, and then you had to add up what each column and what each row was worth. So here I've got star plus star, so I know that's 6 plus 6, plus smiley face, that's 8, so that's going to be 20. Okay. Sorry, guys, I'm not going to write every single one because the presentation is not great. But you understand what we were doing. Now, the challenging question really for this, because the first bit, I'm just adding numbers up. I can do that. Here, I don't know what this is worth. I don't know what my heart is worth. But I do know that my star is worth 6. So star plus 2 lots of something makes 30. That's saying that 6 plus equals 30. Yeah? Now, it's plus 2 lots of something, so it's 2 somethings. That's the heart. Well, let's change it a little bit. Let's think that 6 and something make 30. So what would go there? Well, 6 plus 24 equals 30. So I need to work out what 24 is 2 lots of. And that's where your times tables come in. So Nathan would do that. Drop of a hat straight away. 2 lots of, well done, 12. 2 lots of 12. So you've spotted that the heart is worth 12 there. Okay. So again, you know one thing, you know another thing. So well done, guys, if you've got that. C and D are representing positive integer variables. That means they're numbers. They're values that are positive. They're not negatives on that number line going beneath 0. So C plus D make 5. Basically here, you're working out number bonds to 5. So you've gone straight back to year 1 and reception and you're doing your number bonds. It's not too tricky. So if they're positive, can they be 0, do you think? No, because that's not a positive or a negative value. So the smallest value they could be is 1. So what would 1 go with to make 5? 4. Okay. Then next one is 2. What could 2 go? Yeah, 3. Thank you. Next one is 3. Goes with 2. My handwriting on this computer is awful, sorry. And finally, we've got 4, which goes with 1. Okay, it's not that complicated. I think the language is more complicated than the maths here. Positive integer variable sounds really tricky. It basically means positive numbers. Okay, guys. Moving on now to the next question. Solving these equations then. I think this is where a few of us came a little bit unstuck, but don't worry about it. X plus 3 is 9. Well, something plus 3 is 9. Well, what goes with 3 to make 9 as a sum? 6. Easy peasy. What do I subtract 3 from to make 9? So I've got to add 3 to 9 to make that first value. So that's going to be 12. Sorry. And finally, 3C. That doesn't mean 3 add C. When I put the value, the digit, next to the number, then the representation of C, that means I'm multiplying it. So 3 lots of C make 12. So what do I divide 12 by? I divide it by 3, and therefore I know that 12 divided by 3 is 4. So C is worth 4. Okay. Hassan's got his objects here. 10 grams is on top of this green box, and that's the same as 70 grams. Okay, so what I need to identify then is the cubes. What are they worth? Well, what I can see is that 70, if I got rid of this 10 and I got rid of 10 from here, what would this be? Well, pretty easy, isn't it? 70 subtract 10 is 60. So the mass is 60 grams, okay? So if I got rid of 10 here, I've got to get rid of 10 here. I do one thing to one side, I do it to the other side, and therefore I end up with 60 grams. P is 7. What is the value of 2p plus 9? Well, remember, 2p represented like that means 2 times p. My computer's not being my friend. Now, 2 times p is the same as 2 times 7, which is, Annalie, yeah, 14. So 14 plus 9 is 23. That's a nice 3, isn't it? Well, Mr. Spring, lovely presentation. On to the next one. Bar model is our best friend in the world. Mr. Spring loves the bar model. I'm sure when you're all very, very old and very, very rich and very, very happy, you will still think of Mr. Spring and bar models. So we've got x's, 3x plus 5 along here. So we can see 1, 2, 3x plus the 5, and that equates to, that's the same value as 38. That's why the pink bar at the bottom is the same width as those 4 values combined. Now, I've got to work out what x is worth. Well, first thing I can do, can't I, is I can get rid of 5 from both of these. Okay, so if I make that 5 as well there, I know that now 38 subtract 5 is the same as 3x. So 38 subtract 5 equals 33. And now I know that 33 equals 3x. So what am I going to do with 33? I'm dividing it by 3, aren't I? And therefore I know that x is worth 11 because 33 divided by 3 makes 11. Lovely job. Last couple now. 10y subtract 3 makes 77. Well, again here, inverse operation. Something subtracted 3 makes 77. So if I add 3 to it, then I'll find out what the something was in the beginning. So 77 add 3 makes 80. 80 then equals 10y. So therefore, what I've got to do is do 80 divided by, there's my obelisk sign, divided by 10, okay, which means that tells me that 1y is worth 8, okay? So well done if you managed to do that one. I think we're near the end now. We've got Dexter. He's using this formula to work out the price. So he's selling ice creams, £1.50 S plus 40 TPT. S is the number of scoops, so every scoop costs £1.50, and T is the number of toppings. Okay, so I'm thinking I could spend £20 and have a massive ice cream and then go and see the dentist and be told off. I've got to work out the cost of the ice cream for 2 scoops, so I've got to multiply 150 by 2 and 3 toppings. Okay, so multiplying that by 3. Okay, so that would be £3 because £1.50 times 2 is £3, and then I'm adding it to 3 lots of 40 pence, which would be £1.20, sorry, and therefore I end up with £4. Computer's being annoying. £4.20. And there we've got Libby with an ice cream that costs £2.30. How many scoops could she have? Well, I don't know, do I? Actually, I do, because 1 scoop costs £1.50. So I couldn't have 2 scoops because that would be £3. So she's going to have 1 scoop. And that means that after the £2.30 subtracts the £1.50, I'm left with 80 pence. 80 pence is how many toppings? 2 toppings, isn't it? Okay, so 2 toppings. Lovely ice cream. So there we go, guys. Hopefully you can see all of your answers. I wouldn't have accepted 0 and 5 because I'm a grump and I don't think they count as positive integers. But if you've done 0 and 5 there, you could have got that correct. Okay. And we can see just going through here. If you'd said that 10y equals 80, you could have got 1 mark, but you needed to get that y equals 8 for the 2 marks. Okay. And again here, if you'd said that 3x is 33, that would have been 1 mark, but for the 2 marks, you needed to say that x is worth 11. So you need to go through all the steps. A lot of you saying you felt 2 on confidence. I was surprised because lots of you did really well in this, and well done. I'm really impressed by the maturity for this. Now, when I spoke to you earlier, I said that 3 cubes was worth 60 grams, and I forgot to do the final step, which meant that I only got 1 mark because 3 cubes is 30 grams, but you need to find out that 1 of the cubes is 20 grams. So well done if you've done that. Right, guys, thank you very much for your calculations on algebra. With your calculations down metric measures, you do need to have a really careful look at these. With the metric measures calculations, do look carefully at what you're being asked to. For example, the way you're asked to identify meters. Now, where something's 3 times as long as something, it's a little bit like algebra. So basically, 3 cat equals 1 lion, okay, is almost what we're saying. 3 cat, 1 lion. Guys, thank you very much. You should have got your metric measures and your converting metric measures sheets with your packs today, so you can check through the answers on those as well. Thank you for your calculations and your concentration today. See you soon. Bye-bye.